Let's go ahead and move on to lines in the plane. So one of those concepts that you've been dealing with every year, and it will never go away. Starting with the concept of slope. So think to yourself, what is slope? Hopefully you're thinking to yourself, rise over run. And I'll say, sure, that's how you measure slope, but that's not what slope is. Slope is the measure of the steepness of a line. So the steeper a line is, the higher the slope. The less steep it is, or the more shallow it is, the lower the slope. But of course, we measure slope by finding the rise of the line, in other words, how high up it goes or how low it goes, divided by the run, in other words, the horizontal change in the line. So you may often hear me refer to this as delta y over delta x. Delta, that little triangle right there, is just a Greek letter. It means change. Often we use that letter in math and science to represent change. So the change in y divided by the change in x. Now more specifically, we find the change in y, we find the change in x simply by subtracting. If I start at 7 and I end at 10, I went 3 units. How do I know it's 3 units? Because I subtracted. Where did I end? 10 minus where did I begin? 7. 10 minus 7 is 3. We don't add, we subtract. So anytime you want to know what was the change, we simply subtract the final position minus the initial position. The final number minus the initial number. No matter how big or small those numbers are, always final minus initial will give you the total change. So for change in y, y2 minus y1, x2 minus x1. Now there are 4 types of slope, 4 types of answers that you can get. To start with, if I have something like this, it's going up. As I read it from left to right, it's going up because it has a positive slope. We say that it is increasing. A positive slope means that it is increasing from left to right. Whereas a negative slope means it's decreasing. So if it's decreasing from left to right, it has a negative slope. Now if it's neither increasing nor decreasing, we say that it's constant. The slope is 0. All right? So 0 slope means it's constant. And if it's perfectly vertical, then it has no slope. It is undefined. It is not constant. It is unmeasurable. It is an infinite slope. Whether you say it's infinitely positive or infinitely negative is kind of irrelevant. It is a slope that is undefined. Now there are 3 main equations or 3 main formulas that we can use to write an equation of a line. The first one is point slope form, then slope intercept, then standard form. Point slope form, recall y minus y1 equals slope x minus x1, which is really just a manipulation of the slope formula. Remember, if you think of the slope formula, y minus y over x minus x, and then we just took this entire quantity and multiplied it upstairs, we got the point slope form of a line. If I simplify the point slope form of a line by distributing the slope and then adding the initial y value over, we get slope intercept form, y equals mx plus b. So this form is most useful when you're graphing because we've got the b value, that's our y-intercept. If I plug in 0 for x, this whole term goes away. I'm left with my y-intercept, the b value. And then if I move the x term over to the same side as the y term, we get standard form, ax plus by equals c. Now remember, when it comes to standard form, it's not just x and y are on the same side. The a, b, and c values have to be integers. You can't have fractions for the a, the b, or the c value. So if it's 1/2 x plus 2y equals 5, that's not standard form. We would have to multiply everything by the common denominator in order to get it into standard form. Now technically there is one more form, and that's called the linear function, but it's not really a different form. I call it technically because it has a different name. It's a linear function, but it's really just slope-intercept form. When I say write a linear function, we're going to use function notation, f of x, and we're just going to write ax plus b, where a is the slope and b is still the y-intercept. So that's why I say it's the same form as slope-intercept form, because it has the exact same structure. We're just going to give it a slightly different name. But that doesn't, just because it has a different name, doesn't make it any different. Now, point slope form I've got highlighted here because this is the form that we're going to use when we write equations of lines. Now, technically, you can use any one of these forms to write an equation of a line, but point slope form makes it so much easier for us. In other words, as long as I have the slope and at least one point on that line, I can write an equation of a line using point slope form. If I wanted to use slope-intercept form with the same information, I would have to do some arithmetic to figure out the b value, versus I would already be done with point-slope form. So anytime I write an equation of a line, I'm always going to start with point-slope form. Now, if I, for some reason, need to find slope or slope-intercept or standard form, I'm still going to start with point-slope and then just simplify from there. Now, a handy little trick when it comes to standard form, if you are given standard form and you want to really quickly figure out what the slope is, now of course you could always take standard form and convert to slope intercept, subtract the ax term and then divide by b, or you can realize, hey, I'm just always going to subtract ax and divide by b, therefore the slope is negative a over b. So instead of wasting time manipulating standard form into slope intercept in order to identify the slope, you can really just eyeball it. Negative a over b. The slope from standard form is always negative a over b. Alright, let's practice writing an equation of a line given these two coordinates. So give this a try on your own and then hit play when you're ready. Alright, so hopefully you were able to remember how to do this from all of your previous math classes. I have two coordinates. The first thing I need to do is figure out the slope. I can figure out the slope by using the slope formula, y2 minus y1 over x2 minus x1. Keep in mind I'm subtracting negative 3, double negative is a positive. Clean it up, 5 over 1, or just 5. And then once I have my slope, I can pick either of these coordinates and plug it into point slope form. It doesn't matter which coordinate, either one gives me an equation of a line. So here's my point slope form, plug in the 5, plug in my x and y values. In this case, I chose the first coordinate, and I get this as my final answer. But keep in mind, had you chosen the second coordinate, negative 2, 9, you still have an equation of a line, and it's still a perfectly good answer. Now, you might say, well, don't I have to convert it to y equals mx plus b form? Because my algebra teacher always told me to convert to y equals mx plus b. And I will say, screw what your algebra teacher said. The question says, write an equation of a line. I have written an equation of a line. I have answered the question. The end. Now, sometimes the directions say something a little bit more specific. Always follow the directions. If the directions are vague, then your answer can be vague. But if the directions are specific, you better follow the directions. In this case, it says specifically slope-intercept form. So I have to provide my answer in the correct form that the question asked for. But as I said before, I'm still going to start the same way. I'm going to find my point slope form and then simplify to slope-intercept. So go ahead and give it a try. Hit play when you're ready. Alright, find the slope, y2 minus y1, x2 minus x1, clean it up, I get 11 over negative 7. Can't simplify that any further. I'm going to leave it in the fraction form. Do not ever convert a slope to decimal. Slope is rise over run. It is a fraction. It should always be represented as a fraction. So I'm going to leave it as negative 11 over 7. So here's my point slope form, which I always start with. I don't care what the directions say. I'm going to plug in my slope, and I'm going to go ahead and pick one of these coordinates at random and plug everything in. So by picking at random, I am always going to pick the first coordinate because it really doesn't matter what random is. So y plus 6 equals negative 11 over 7, x minus 4. Now, this is not my final answer. The direction said slope-intercept form, so I'm just going to take this and simplify. That slope can be distributed. Negative 11 over 7 times x, and negative 11 over 7 times negative 4. So obviously negative 11 over 7 times x is just negative 11 over 7x. Negative 11 over 7 times negative 4, a negative and a negative is a positive. A fraction times a number just means multiply the number times the numerator, not the denominator. 11 times 4 is 44, so I get 44 over 7. So now to get it in slope-intercept form, I got to get the y by itself, so I will subtract the 6 from both sides. Subtracting the 6 means I need to subtract the fraction and the 6. Remember that 6 is really a fraction, 6 over 1, common denominator of 7. So if I convert the 6 into a fraction with a denominator of 7, it becomes 42 over 7. 44 minus 42 is 2 over 7. So I have my slope-intercept form, negative 11 over 7x plus 2 over 7. All right, let's try it again. This time I want to write as a linear function, but keep in mind what I said about linear functions. Linear functions are the same thing as slope-intercept form. So in other words, I'm writing y equals mx plus b, but instead of saying y equals, I'm going to say f of x equals. Since the directions say function, I'm going to use function notation in my final answer. Now notice the coordinates are presented a little bit differently. They're presented using function notation. That's no problem. They are still coordinates. Remember, this says f of x, so the x value is 2, and f of x is another way of saying y, so the y value is 5. So I have the coordinates 2, 5, and negative 3, 1, y2 minus y1, x2 minus x1, 1 minus 5, negative 3 minus 2. So double negative is a positive. I have a slope of 4/5. So I will now follow the exact same process I did in part B, starting with my slope-intercept form. My point-slope form. Plug in my numbers. I chose, once again, the first coordinate, 2, 5. Distribute the slope. 4/5 times negative 2 is just negative 8/5. Add the 5 to both sides. 5 as a fraction is 5 over 1. If 5 is the denominator, then it needs to be 25 over 5. So I have negative 8 plus 25, which is positive 17. So 4/5 x plus 17/5. Notice I switched from y equals to f of x for my final answer since it did ask for a function. Now let's remember about parallel and perpendicular lines. Write an equation of a line that passes through the point 2, negative 1 and is parallel to 2x minus 3y equals 5 and perpendicular to 4x plus 8y equals 10. Remember, parallel lines are lines that never intersect. They do not cross at any point. They just follow the same path, go in the same direction forever. In other words, they have the same slope. Parallel means the slope is the same. So if it has to be parallel to this line, then it has to have the same slope. So what we can do first and foremost is figure out the slope of this line. Well, remember, this is in standard form, and we have a quick little shortcut to find the slope in standard form. It's just the negative a value over the b value. So the a value is 2, so I'm going to say negative 2 over negative 3. So the slope, negative a over b, should be negative 2 over negative 3, or 2/3. So instead of having to actually convert this into slope-intercept form to find out what the slope is, we can just use that quick little formula, negative a over b, to very quickly figure out what the slope of the given line is. So the slope of the given line is 2/3. So therefore, the slope of the parallel line is also 2/3. So there's a slope. It's got to go through this point. So I can use my my point slope form and write my equation of a line, y plus 1 equals 2/3 x minus 2. Now remember, for perpendicular, parallel means same slope, perpendicular is opposite reciprocal. So if I have a slope of, let's say, negative 4 over 8, in other words, a slope of negative 1/2, opposite reciprocal means I need to flip and switch. So I need to flip 1/2 to become 2 over 1 and switch the sign from negative to positive. So my perpendicular slope will just be positive 2. So there's my slope, still have the same coordinate. So my line is y plus 1 equals 2x minus 2. All right, let's try it again. See if you can catch what I'm throwing at you. Alright, so this one looks a little bit differently, but not if you know what you're doing. Now, of course, I have a coordinate pi e. That's crazy talk. Well, pi is just 3 and change, and e is just a little bit less than 3. So I have a coordinate that's just an ugly number, but it's still a coordinate. Parallel to x equals 4. Well, what is x equals 4? When I have x equals a number, remember, that's a vertical line. The slope is undefined. So if it's parallel to a vertical line, shouldn't it still be a vertical line? In other words, it's got to have the same slope. So if the slope of x equals 4 is undefined, then the slope of the parallel line will also be undefined. So I just need another line that's x equals a number. But I wonder what x value we're going to choose. Well, obviously, it's got to go through this coordinate. So that means the x value has to be pi. So parallel to x equals 4 would be x equals pi, the vertical line going through x equals pi. Perpendicular to a vertical line, well, that's a horizontal line. How do we write a horizontal line? Not x equals a number, but y equals a number. Well, what y value should I choose? Obviously, it's going to be e, so it's the horizontal line going through the value e, 2.718. So next, let's talk about graphing. So here are 3 lines that we want to go ahead and practice graphing. Hopefully remember how to do this. So go ahead and take a moment, try it on your own, and hit play when you're ready. All right, let's look at the first one. 2x minus 5y equals 15. So we remember when we are graphing lines, we need to make sure that it's in the proper form, y equals mx plus b. So the first thing I'm going to do is rewrite the equation so that y is by itself. So I see that the 2x is in the wrong spot, so I'll move the 2x to the other side. Anytime I move a term across an equal sign, it's going to change the sign, so that becomes a negative 2x. Now notice I put the negative 2x in front of the 15 instead of in the back of the 15, because I know my standard form is mx plus b, so it makes more sense to put the x term first and the constant term last. So then let's get rid of the negative 5 by dividing everything by negative 5. Negative 2 divided by negative 5 gives me a positive 2/5. 15 divided by negative 5 gives me a negative 3. So now I have my y-intercept of negative 3, and I have my slope of 2/5, my rise over run. So now I'm ready to graph. So I'll start with my y-intercept, which was at negative 3, starting at 0, going down 1, 2, 3, y-intercept of negative 3. And then I had my slope of 2/5, so starting at my y-intercept, go up 2 over 5. Now, I could just draw my line straight through these 2 points because I only need 2 points to draw a line, but I always like to make sure my line is perfectly straight by following that slope over and over and over again until I have gone the entire length of the provided axes. So I will go up 2 over 5 one more time. I see my dot right over here on the extreme right edge. So then I'll go back to my y-intercept and back up my slope. Instead of going up 2 over 5, I'll go down 2 over 5. Down 2 over 5 one more time gets me to the extreme left edge. So now I can draw my perfectly straight line connecting all of the points on my graph. So let's look at the second one. This time the y is almost by itself. All I have to do is divide by 5 and y will be by itself. So when I divide by 5, 4 becomes 4/5, 5 becomes 1. So I have y equals 4/5 x plus 1. I've got my y-intercept of positive 1 and my slope of 4/5. So once again, I'll plot my y-intercept at positive 1, and then I will follow my slope of 4/5, up 4 to the right 5. I can't go up and over anymore, so then I'll try backing it up, down 4, left 5, and I notice I can go one more time, down 4, left 5, and I've got my last point over here, connect the dots with a perfectly straight line. And the last one. This one, the only change is that the x and y, it's not in standard form, the x and y are reversed, but it doesn't really matter. Let's take the 8x, move it over, and then divide everything by 2. This time I have a slope of negative 4. Now remember, slope is a fraction, so that negative 4 really says negative 4 over 1. So when I read my slope, I don't just think down 4, it's down 4, right 1. So I have my y-intercept at 5, which is right here, and my slope is down 4, right 1. Down 4, right 1, down 4, right 1. Connect the dots, I have my perfectly straight line.